Imagine you're a German panzer commander in 1943, entrenched in the dusty, unforgiving terrain of Tunisia. The North African sun beats down, artillery shatters the air, and through the haze of battle, you see them. American Sherman tanks. Not the fearsome tigers or panthers of your own arsenal, but the inferior Shermans, often dismissed as lighter, less powerful. Yet, what you're witnessing defies logic, defies all Wehrmacht doctrine. It's February 20th, 1943, north of Kasserine Pass, and your battle reports will struggle to capture the profound bewilderment spreading through your ranks. 5 Shermans, scattered across broken ground, with no line of sight between them, are converging on your positions, not as individual vehicles, but as a single, telepathic organism. They move with an impossible, almost supernatural coordination. No flags wave above their turrets, no flares signal intentions, no dispatch riders race recklessly between them. Yet, each tank perfectly covers the blind spots of the others. Each crew knows, with uncanny precision, exactly where their comrades are, what they're doing, and where they're going. This sight is pure nightmare fuel. How could this be? In your own Panzer V's, equipped with the state-of-the-art FUG-5 radios, your commanders are struggling just to hear their own company leaders. The air is thick with static, overwhelming your Amplitude Modulation, AM systems. Your 10-watt transmitters, considered advanced in the 1930s, can barely cut through engine noise for a few hundred meters when you're moving. And most of your tanks, they only have receivers capable of hearing orders, but utterly deaf when it comes to reporting enemy positions or calling for desperate help. You're isolated, fighting individual battles in a chaotic symphony of war. So, how did the Americans manage this seemingly impossible feat? How did these inferior tanks achieve a level of battlefield synchronization that German high command, with all their tactical brilliance and superior doctrine, deemed utterly impossible without visual contact? Were they simply better trained? Was it sheer, incredible luck? Or was there something else at play, an unseen advantage that rewrote the rules of engagement right before their very eyes? This incredible coordination wasn't magic, nor was it sheer luck. The secret lay in an invisible force, a silent revolution brewing in American factories. What if the decisive edge in a tank battle wasn't a bigger gun, but a crystal clear voice cutting through the deafening chaos? The nightmare at Kasserine Pass, the uncanny American coordination, it wasn't magic. It was the silent revolution of frequency modulation, or FM radio. While German panzer commanders wrestled with static-choked communications, American tanks were operating with a technology the Germans didn't even know existed, transforming mere whispers into battlefield roars. To truly grasp this revolution, imagine listening to a radio station in a thunderstorm. That crackling, fading signal, that's amplitude modulation, or AM, the system powering the German FUG-5 radios. AM radios convey sound by varying the strength of the radio wave. Unfortunately, every electrical discharge, from a tank's engine to nearby artillery, also varies that strength, creating interference that drowns out the message. It's like trying to have a conversation in a crowded, noisy factory. Every shout and bang becomes part of the message itself. This was the deafening reality for German tank crews. Their 10-watt transmitters, while cutting edge in the 1930s, simply couldn't penetrate the cacophony of the battlefield for more than a few hundred meters. Now, imagine a different kind of radio. One where the signal is so robust, so clear, that even a raging thunderstorm sounds like a gentle patter. That's frequency modulation. Invented by the brilliant, but often overlooked, Edwin Howard Armstrong. FM carries sound by varying the frequency of the radio wave, not its strength. This simple, elegant difference meant that battlefield noise, which was mostly amplitude-based, could be largely filtered out. Suddenly, a crystal-clear voice could cut through engine roar, cannon fire, and exploding shells like a knife through butter. This wasn't some distant laboratory experiment. This was the future of battlefield communication, brought to life by American ingenuity. The transformation began on July 22, 1941, when the U.S. Army standardized the SCR-508 radio series for all medium tanks. Spearheading this innovation was the Galvin Manufacturing Company, soon to be known as Motorola. Their engineering dream team included Daniel E. Noble, who conceived the application of FM in military vehicles, and Henryk Magnuski, the principal RF engineer who painstakingly solved the immense technical challenges of installing sophisticated electronics into the brutal environment of a tank. Their creation, the SCR-508, was a revelation. It provided 25 watts of transmission power, 2.5 times the German Fuji-5's output, and its crystal-controlled precision ensured stable, preset channels. No more drifting off frequency mid-battle. Most critically, it delivered a clarity that was previously unthinkable. It meant that every American tank commander could not just hear, but understand orders, warnings, and intelligence, even as battle raged around them. It was the decisive edge, not in raw power, but in pristine communication, turning every American Sherman into a listening and speaking node in what would become the world's first true battlefield network. But technology alone isn't enough. It's about how it's deployed, and America didn't just have better radios. They built the world's first battlefield network. While German tanks struggled to hear their own leaders, every American Sherman was a node in a living, breathing battle network. How did they achieve this unprecedented scale? The answer wasn't just superior technology, but an industrial commitment unlike anything the world had ever seen. Building on the foundation of FM radio, American engineers didn't just create a better radio. They engineered a revolution in battlefield connectivity, deploying it on a scale that baffled their enemies. The heart of this revolution was the SCR-508 radio family. Robust, reliable, and designed for the chaos of combat. Let's talk specifics. The American SCR-508 transmitter boasted 25 watts of power, 2.5 times the output of the German Fuji-5. This meant a significantly greater range, transforming battlefield distances from hundreds of meters to several miles. But power was only half the story. The SCR-508 used crystal-controlled frequency stability. Think of it like a perfectly tuned instrument. Once set, it stayed precisely on frequency, regardless of the tank's movement or the shock of a nearby explosion. German Fuji-5 radios, relying on older variable capacitor tuning, constantly drifted, forcing crews to spend precious combat seconds retuning their sets, often through a haze of static. Crucially, the SCR-508 system included not one, but two BC-603 receivers. This allowed American commanders to monitor their immediate platoon network and the company command net simultaneously, ensuring orders flowed instantly while maintaining real-time awareness of subordinate positions. Furthermore, an integrated BC-606 intercom system meant every crew member could communicate clearly, alerting the commander to threats or relaying vital information through throat microphones and noise-canceling headphones. Many German tanks, by contrast, lacked any internal intercom, forcing crews to communicate by shouting or touch, a dangerous, inefficient practice in a rumbling, deafening tank. Now, here's the truly staggering part: the production miracle. While Germany was struggling to equip perhaps 1 or 2 command tanks in a 5-vehicle platoon with a basic transceiver, leaving the rest with only receivers, America achieved 100% deployment of the sophisticated SCR-508 in every single Sherman tank. Imagine the sheer industrial might required. From Motorola's Chicago factories, which had once churned out car radios, came over 50,000 SCR-508 family radio sets during the war. This meant that every one of the 49,364 Sherman tanks produced had a crystal-clear, powerful, and universally compatible radio system. This wasn't just about manufacturing radios. It was about building a military doctrine around the assumption of flawless, universal communication. While German tank commanders scanned for visual signals or strained to hear static-ridden orders, every American Sherman was an active, communicating node in a cohesive battle network, ready to transmit, receive, and coordinate. This wasn't just about technical specifications. It was about fundamentally transforming how battles were fought, and the results on the ground were nothing short of astonishing. So, how did this invisible weapon rewrite the rules of tank warfare, turning what seemed like numerical inferiority into decisive victory? The impact was immediate and utterly baffling to the German High Command. Remember Kasserine Pass, that opening mystery? Those German commanders, witnessing American Shermans move with telepathic precision, truly believed it was a fluke, a product of rigorous training. They couldn't fathom that these inferior tanks were merely nodes in a living, breathing battle network, coordinating across miles of broken terrain, while their own commanders struggled to hear orders through a haze of static. This initial shock was just the beginning. As the war moved to the rugged mountains of Italy in 1943, the SCR-508's worth truly shone. What should have been a communications nightmare, steep valleys, blind corners, limited line of sight, instead became a playground for FM-equipped Shermans, where German AM radios dissolved into useless static. American tanks maintained crystal-clear voice contact, coordinating attacks and covering each other through terrain that would have crippled any unnetworked force. Visual signals were often impossible, but the unseen hand of FM radio guided every move. Then came the brutal hedgerow fighting of Normandy. Here, a new challenge emerged. Tanks couldn't talk to infantry. Sherman radios operated on a different frequency range than the infantry's SCR-300 walkie-talkies. This deadly communication gap left tanks vulnerable to Panzerfausts lurking in the dense foliage. But American ingenuity, fueled by the demand for connectivity, found a solution in weeks. Tank crews simply wired standard EE-8 field telephones into their internal intercoms and mounted them on the tank's exterior in ammunition boxes. A simple, yet revolutionary modification that allowed infantry to literally plug in and talk directly to tank crews, transforming tank infantry cooperation in the deadly bocage. By Operation Cobra in late July 1944, this unseen hand had evolved into an iron fist. Major General Edward H. Brooks's 2nd Armored Division orchestrated over 200 Sherman tanks, moving as a single, devastating entity. German defenders from the once mighty Panzer Lehr Division faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by units miles away. Artillery strikes arrived within minutes, precisely guided by tank commanders. The contrast with the German situation was stark. Panzer Lehr, once famed for its communication, now had most tanks operating without radios, relying on hand signals in terrain where visibility was often under 100 meters. This technological blind spot proved catastrophic time and again. At Arracourt in September 1944, the American 4th Armored Division, with their supposedly inferior Shermans, went toe-to-toe with multiple German panzer brigades equipped with superior Panther tanks. The Germans held every advantage in armor and firepower. But American radio coordination was decisive. Every Sherman became an instant spotter, reporting enemy positions. Tank destroyers received targeting information from units they couldn't see. Artillery observers in Sherman command tanks called in barrages within minutes, often catching the Panthers by surprise. Over 3 weeks, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a 7.1 kill ratio that defied technical specifications. Yet, through it all, German intelligence failed to grasp the true significance. A captured September 1944 intelligence assessment stated, and I quote, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures. They completely missed the technological chasm, attributing it to training instead of the revolutionary FM radios. This fundamental misunderstanding led to critical tactical blunders. Germans continue to target command tanks based on their antenna configurations, unaware that every Sherman could perform command functions. They planned ambushes, assuming American units would lose cohesion when separated by terrain, not realizing that radio contact maintained unit integrity regardless of visual line of sight. Fast forward to March 1945, as American forces neared the Rhine. The capture of the Remagen Bridge demonstrated the breathtaking speed of American command and control. When the Ludendorff Bridge was discovered intact, radio reports reached 1st Army headquarters within minutes, and divisions across the front shifted within an hour to exploit the opportunity. German forces, reliant on fragile telephone lines systematically destroyed by Allied air power, couldn't respond with comparable speed. The subsequent defense of the bridgehead was an impenetrable wall of coordinated fire, with tank platoons from different battalions integrating seamlessly through their radio networks. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed in detail. The encirclement of the Ruhr pocket in April 1945 saw the culmination of American communication superiority. 2 entire armies, the 1st and 9th, coordinated a complex double envelopment entirely through radio. Inside the pocket, 325,000 German troops were trapped, their communications collapsing around them. Field Marshal Walter Model's final, desperate messages before losing contact entirely painted a grim picture. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. The American communication advantage wasn't just a tactical edge. It was a force multiplier, transforming every engagement and exposing German blind spots that proved fatal. The impact of this communication superiority wasn't just tactical. It reshaped the entire psychological and strategic landscape of the war, leaving a legacy that still influences military doctrine today. Could it be that the ultimate lesson of World War II wasn't about bigger bombs or thicker armor, but about better conversations? As we've seen, the true game changer wasn't a larger gun or heavier plate, but the invisible network woven by the SCR-508 radio. This wasn't merely a technological upgrade, it was a profound paradigm shift, proving decisively that information dominance and battlefield connectivity could consistently trump what seemed like platform superiority in armor and firepower. Think for a moment about the profound psychological impact this had on the men inside those steel boxes. For American tank crews, even when physically isolated by terrain or smoke, they were never truly alone. A crystal-clear voice linked them to their comrades, to command, to artillery support, creating a collective intelligence that fostered confidence and cohesion. Imagine the sheer mental burden lifted, knowing you could instantly call for help or warn a friend. Now, contrast that with German crews, often fighting in profound isolation. Unable to communicate beyond a few hundred static-ridden meters, they fought individual battles within larger engagements, making quick, coordinated responses almost impossible. Their initial advantages in tank quality were utterly negated by this communication chasm. Field Marshal Wilhelm Keitel, whether his quote is perfectly accurate or merely apocryphal, is said to have remarked at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together." This statement perfectly encapsulates the German failure, an intelligence blind spot that persisted throughout the war. Despite countless battlefield encounters demonstrating American coordination advantages, German leadership never prioritized solving their critical communication weakness. They continued building individually superior tanks that fought as isolated individuals, while America built adequate tanks that fought as devastatingly coordinated teams. The legacy of the SCR-508 resonates far beyond the 1940s. It fundamentally initiated an invisible shift in military affairs, establishing principles that govern modern warfare. When the Bundeswehr was rebuilt in the 1950s, it prioritized communications based directly on these World War II lessons, ensuring every Leopard tank carried comprehensive radio systems. Look to the Gulf War in 1991, where coalition forces with superior communications overwhelmed Iraqi forces equipped with individually formidable Soviet-designed tanks, but inferior radios. Or in 2003, where American forces again demonstrated that network-centric warfare consistently defeats platform-centric warfare. The core lesson remains: connection equals survival, and isolation equals defeat. The electromagnetic waves carried by those 181 pounds of radio equipment in every Sherman tank proved more powerful than the armor-piercing rounds fired by any German 88 mm gun. The ability to coordinate, to share information instantly, to fight as a unified force rather than as individual vehicles. This invisible advantage determined victory more surely than any visible superiority in armor or armament. The SCR-508 didn't just transform the M4 Sherman. It transformed warfare forever. It taught the world that the network would defeat the platform, and the connected would overcome the isolated. What unseen forces in history, or even in our daily lives, do you think have had a similar, quietly transformative power?